Okay, so we just talked about T cytotoxic cells, so let's talk about what's called a natural killer cell. So, natural killer cells. These are also referred to as NK cells. So natural killer cells kind of act the same way as T cytotoxic cells, except instead of looking for this MHC1 on normal cells, and seeing what antigens presented on there, instead these are going to look for cells that don't have MHC1. So natural killer cells, we're going to have a nucleated cell. Man, this marker. So a nucleated cell lacking MHC1. So if you have a nucleated cell and it's lacking MHC1, this is not good. This is going to be a cell that's going to be probably either infected by a virus or it's going to be cancerous. So either way, we don't want to keep this cell around. It's going to cause our overall body, more harm than good. So what's going to happen then is here's our host cell, and it's going to be, contaminated or contaminated. It's going to be infected or it's going to be cancerous. So it's sad. It no longer has its normal healthy MHC1 like we saw up here. So we'll just remind everybody that real fast. So if it's lacking MHC1, it's going to be, either infected by a virus or cancerous. But if it was a healthy nucleated cell, remember this would have the MHC1 present. So host, we can see these lack MHC1. So host cells that are infected by a virus or that are cancerous lack MHC1. So that's not going to do any good if we have a T cytotoxic cell, right? It'll go around like, oh, MHC1, sweet. Then it'll come out of this one. It's like, nothing here, move on to the next one. So we need an immune cell that's going to be able to recognize that this one, this host cell should have an MHC1 but doesn't. So that's where the natural killer cells come in. So natural killer cells, let's label it NK. These are going to come through and they're going to look for MHC1. So they're like beeping all around, and they're like, okay, nothing is here. We do not see any MHC1. So the natural killer cells are going to go ahead and, just like the T cytotoxic cells, they're going to release these cytotoxic proteins to kill off the host cell. Okay, so if a natural killer cell, though, came here to the healthy cell, it would say, oh, hey, you have MHC1. Awesome. See you later. And you'd get, no reaction. All right. So that's the natural killer cells. So natural killer cells too, besides just killing off infected hosts, we're going to see too as a side job, they can also, let's put here, NK cells can also attack parasites. Through what's called this antibody mediated mechanisms. So we'll see later when we talk about this, but what can happen, here if we have little small cells like this in our body, what if we get a big parasite? What will happen is you can get these antibodies that bind to this parasite, and that's going to signal your natural killer cell to, shoot a whole bunch of those little cytotoxic proteins at it to kill it off. Okay. But let's just go ahead and quickly review the differences again between the T helper cell, T cytotoxic, and natural killers. So T helper cells, these are going to be this is going to be useful in trying to kill off different viruses, different bacteria, that type of thing that's hasn't quite gotten into the host cell, but maybe could at some point. So the T helper cells, these have a T cell receptor on them that are going to go through and interact with MHC2 that's found on these antigen presenting cells. So remember, antigen presenting cells, they gobble up different pathogens in the environment, they chop them up, and then they present that little piece of the pathogen on the MHC2. So when the T helper cell interacts with MHC2, it's going to say, hey, there's this antigen that's present. We know there's a bad pathogen around here somewhere. So it yells for help. It calls for backup. It tattles on, the pathogens there. So you get all these other immune cells that come there. You get macrophages, B cells that become activated. Neutrophils come to that site, and you get T memory cells that are produced. So T helper cells yells for help. T cytotoxic and natural killer cells, these are going to be, immune cells that kill off cells, our own host cells that are infected or that have cancer. So we said T cytotoxic cells, these are going to go around and interact with MHC1. So MHC1 is found on normal cells, the healthy ones. So any nucleated cell that we have in our body should have MHC1 on it that interacts with these T cytotoxic cells. So T cytotoxic cells will go up to healthy cells and they're like, oh, nothing bad here, we'll move on. But when it gets to an infected cell, maybe one that has cancer, one that's going to be, infected by a virus, then those cells are going to be producing this abnormal antigen. So the T cytotoxic cells, like, oh my goodness, like this has, abnormal antigen here. That means there's a pathogen or this cell's cancerous. We better kill it off. So it becomes activated, becomes a cytotoxic T lymphocyte or CTL, and then that produces all these cytotoxic proteins and kills off this, bad cell. So natural killer cells are, they kind of have the same mechanism where they release these cytotoxic proteins. But these natural killer cells instead are going to be going ahead and looking for the presence of MHC1. So natural killer cells, like, sweet, this one has MHC1, like, you're still healthy. And then it moves on to the next cell and it's like, oh my goodness, MHC1 is gone. That means, you're either been taken over by a virus or, this is cancerous cell, we need to kill it off. So it'll release those cytotoxic proteins, just like what we saw with T cytotoxic cells, to kill off the infected cell or the cancerous cell. So natural killer cells, we'll see this again later in the chapter, just briefly, but they can also attack extracellular parasites as well.